All right, everybody, welcome back. So in this video, we're going to look at C and D, and this is called probability. So the chances of one event occurring given a total, the chances of a certain amount of things happening from a total. And what I'm describing here is really division. So the number of possible things divided by the total. Now, believe it or not, the most important thing here is going to be this, and I've attached this into your sheet. And this is a standard deck of cards. So this is going to be a little cheat sheet for you all. And in cards, you've got hearts, diamonds, spades, clubs, and they go from aces to kings. It's important to have this because I need to know the total possible positive outcomes versus the total. And most of your probability problems here will revolve around a deck of cards. So I've given this to you so you don't have to worry about knowing what is in a deck of cards. And here's what we do. You can see I've got find the probability, and this is our notation for probability here, that I'm going to choose a heart from the total. Well, when I come back to my cheat sheet, I can see here's my hearts, and how many total hearts are there? Well, there's 13. How many total cards are there? There's 52. So the probability of a heart is 13, the total of positive outcomes that will give me what I want, over the total number of options. So the total positive outcomes versus the total outcomes, and this will give me 0.25, which will make 25% chance. And we're going to put our probabilities in terms of percentages. Okay, in number 2, you can see now I'm going to do two different things. I want to know the probability that it's jack or red. So when I come here, I've got 26 red cards. You can count those up. There's 26 there. In addition, I've got 4 jacks. So here's my 26 reds and my 4 jacks. The question is, how many total positive outcomes do I have? Well, the red jacks are already included in my 26 reds. So I only need to add in 2 more additional positive outcomes for these 2 jacks down here. Let's go ahead and get, I'm going to use this slide a lot. So 26 plus 2 is 28. There's still 52 cards total, 52 card pickup. Ever hear that game? Because where you throw the cards on the ground, they got to pick them all up. So 28 divided by 52. I get 0.538 and some change, and we'll round that to 54%. So total positive outcomes divided by total outcomes. Okay. Here we go with another one. Now it gets a little more complicated. In this one, I want both. It has to be a queen and a black one. So when I look here, there's only 2 queens that are black. So the total positive outcomes here are simply 2 out of 52. And when I divide that, I get 0.038. So we're around that to 4%. Again, total positive outcomes divided by total outcomes. Okay, now you get into problems that don't require that knowing the cards, and M&M seem to be the next likely source. So in this problem, I've got 3 plus 4 plus 5. I've got 12 total M&Ms. So it's always hopeful to have that. Now, what's the probability that I pick a red one? Well, how many red M&Ms are in this bag? This is kind of weird. There's none. So it's a 0% chance. What's the probability of a blue one, let's say? Well, a blue one, just so we have one that actually works, would be 3 out of 12. which would be 25% chance. Okay, you can do the same thing with jelly beans. So in this one, I've got 15 total, and I want a green or a red. Well, there's 6 green plus 7 reds, so there's 13 positive outcomes. Divide by my total, and we're going to round it to 87%. This is all probability is, total positives versus total. Whoops. Okay, we're back to cards, but this is not cards at all. It's just numbers 1 through 15. And inclusive simply means that 1 and 15 are in this possibility. So there's 15 total. If I said exclusive, I would say only 2 through 14. So there are 15 total outcomes. And let's see, there are, ooh, this is going to be a fun one. Even numbers, so it's got to be even. So it's 2, 4, 6, 8, 10, 14. Now, are there any other numbers that are divisible by 7 that aren't included in here? And there is. There's one more. It's 7. So 1, 2, 3, 4, 5, 6, 7, 8 out of 15. And we're going to get 53%. Total positive, divide by total. And when we get into the last couple sections here, we're still doing that same thing. Now, in this case, my total outcomes are going to be 6. And what is the probability of a 2 or a 5? Well, that's going to be 2 divided by 6 is 33%. Total positive, divide by total. Okay. Now, this I will let us skip here. We won't worry about that one where I give you that. But now we're going to start doing more than one probability. So here's what happens. This goes back to our multiplication principle. 4 cards are chosen without replacement. What's the probability of drawing 4 hearts in a row? So there's 4 total things that are going to happen here. So to get my answer, I'm going to have to multiply them all together because I want all the combinations. Well, my first probability would be 13 hearts out of 52. Now, it says with replacement, so what's going to happen after I draw that, I'm going to put it back in, I'm going to start over. If I said without replacement, this next deck would be 51 because I've already been 1 card short. I don't need to worry about that here. I'm just going to do that. And it's always going to be real small. In this case, it's 0.4%. And you see, that's what's going on here in the rest of these. So this one's without replacement. So I'm going to draw 2 cards. My first card's going to be out of 52, and there's 4 kings in the deck. Now, it says without replacement. So that king is already gone. And I'm 1 card short, but I've already taken 1 king out. So there's my chances of drawing the new king on the next one. And what I'm going to get is 0.5%. Be careful that you're not putting 5%. It's 0.5%. Okay. And again, we're not going to worry about these where the percentages are already given to you. Although, we really probably could. I mean, it's not anything you can't do. But no, we won't worry about that. So I think we're going to be it. Yep. Okay. So there you go. The only probabilities I'm going to have you worry about today will be the ones where you have to calculate on your own. All righty. Are there any questions on this? Go ahead and ask. And if not, practice the rest of this packet, and we'll be ready for a quiz at this at some point. Good luck.